Semiconductor Packaging. John D. Thomas, Alex Ruth. Book 5, Section 2, Chapter 3, Topic 1.
Semiconductor packaging is a pivotal stage in the production of integrated circuits, ICs, that transforms individual semiconductor dies into functional electronic devices ready for use in various applications. Assembly encompasses a series of intricate processes aimed at mounting, interconnecting, and encapsulating semiconductor dies onto carrier substrates, ensuring reliable electrical connections and mechanical support while protecting the delicate components from external factors. In this comprehensive overview, we will explore the assembly of a semiconductor package, elucidating the fundamental steps, techniques, and considerations involved in this crucial stage of IC manufacturing. Introduction to Semiconductor Packaging Assembly. Semiconductor packaging assembly is the process of transforming individual semiconductor dies into fully functional packaged ICs ready for deployment in electronic systems. It involves a series of precise and controlled steps aimed at mounting the dies onto carrier substrates, forming electrical connections, encapsulating the components, and ensuring the reliability and performance of the packaged devices. Die mounting. The assembly process typically begins with die mounting, where individual semiconductor dies are affixed onto carrier substrates or lead frames. The method of die mounting varies depending on the package type and design requirements. Common techniques include epoxy or adhesive bonding for surface-mounted packages and soldering for through-hole or flip-chip packages. Die mounting requires precise alignment and placement to ensure proper electrical connections and thermal dissipation. Interconnection formation. Once the dies are mounted, interconnections are formed to establish electrical pathways between the die and the external leads or contacts of the package. Wire bonding is a widely used technique for creating these interconnections in traditional packages, where fine wires are bonded from the die pads to the package leads using ultrasonic or thermocompression bonding. In flip-chip packages, solder bumps or conductive bumps are used to create direct connections between the die and the substrate. Encapsulation. After interconnection formation, the semiconductor package is encapsulated or sealed using material such as epoxy resin or molding compound. Encapsulation provides mechanical support, environmental protection, and structural integrity to the packaged ICs, shielding them from moisture, dust, mechanical stress, and other external factors. Encapsulation may involve transfer molding, compression molding, or other molding techniques depending on the package type and production requirements. Thermal management. Thermal management is a critical aspect of semiconductor packaging assembly, particularly for packages with high power dissipation requirements. Heat sinks, thermal pads, thermal vias, and other thermal management elements may be integrated into the package design to facilitate heat dissipation and regulate operating temperatures. These elements help prevent overheating and ensure optimal performance and reliability of the packaged ICs. Testing and quality assurance. Throughout the assembly process, packaged ICs undergo rigorous testing and quality assurance measures to verify their functionality, performance, and reliability. This includes initial testing to detect defects, functional testing to assess product features, and final inspection to ensure adherence to specifications and standards. Testing and quality assurance procedures may vary depending on the package type and the complexity of the integrated circuits. Marking and packaging. Once tested and inspected, the packaged ICs are marked with serial numbers, date codes, or other identifying information using laser marking techniques. They are then packaged into trays, tubes, or reels for shipment to customers. The marking and packaging process may vary based on the package type, customer requirements, and industry standards. Future trends and innovations. As semiconductor packaging technology continues to evolve, new trends and innovations are emerging to enhance the efficiency, reliability, and performance of packaged ICs. This includes the adoption of advanced materials, manufacturing processes, and design techniques to improve thermal management, reduce form factor, increase functionality, and meet the evolving demands of the electronics industry. In conclusion, semiconductor packaging assembly is a complex and multifaceted process that plays a pivotal role in transforming semiconductor dies into functional electronic devices. By understanding the fundamental steps, techniques, and considerations involved in semiconductor packaging assembly, manufacturers can ensure the quality, reliability, and performance of packaged ICs, driving innovation and advancement in the electronics industry. Thanks for watching.
Please like, share, and subscribe.